Oil-based lubes.
Yeah.
Why is it based?
Cool.
I'll just take a screenshot later.
Great.
Welcome back to another episode of Atoms and Bonds. My name is Adam Rosenzweig, and this is the show where I, a real-life scientist, do a chemistry experiment with the help of a fabulous drag queen. Today, Oiga Vault, it's Hanukah Lewinsky.
Hi, Adam. I'm so happy to be here.
Thank you so much for coming. Well, thank you so much for joining us in the lab today. Please tell us a little bit about you.
I'm a New York City drag queen. I like billing myself as New York City's Jewish star.
Because Miss Cracker is on tour.
She's busy. But I will happily take her place in the meantime.
So, tell us about any experience that you might have with science or chemistry.
I did fail pretty much every science class in school, much to my mother's chagrin.
Mm-hmm.
I famously failed biology because I didn't ask for her help. She is a biologist. Why I didn't ask?
That's so cool that your mom's a scientist. We have a second-generation scientist in the lab today. Ugh.
Shout out to Dr. Heidi Tissenbaum.
Yes!
For you.
She has her own lab. That's like, that's so cool. Miss Hanukah.
Yes.
You are of Jewish descent.
I'm not, actually.
Oh, shit.
No, I am.
My last name is Rosenzweig, so
Famously
I,
Jewish.
too, come from some Jewish descent. And you're named for the miracle of the oil lasting in the temple for 8 long days.
8 long nights, 8 long nights.
8 long nights.
See, he's half Jewish.
So I got it.
He only gets half the story right.
So when I was thinking in my little science brain about what experiment we could do, I was thinking that we could take the miraculous oil that lit the way for our people for millennia and turn it into soap. So in today's experiment, we're going to be taking cooking oils and converting them into soap. People have been doing it for thousands of years, but today we're going to just hit on the scientific concepts behind it.
Great.
So the main things that we're going to want to talk about is that this whole reaction is a process called saponification. And then another little bit that we'll talk about is molecules with a property called being amphipathic. But we can get into all of that later. Because this takes a little while to stir and get a little bit going, we're just going to jump right in.
Great.
Obviously, the first thing we have to do before all of that is we have to get into our PPE.
Pretty exclamation point.
So let's go get pretty exclamation point, and we'll be right back.
Perfect.
Now that we're ready to go, we're just going to run down the line introducing all of our experiments for the day, and we'll get cooking ASAP. Presented to the cameras.
We have Ms. Olive Oil. Olive. Oliva oil.
Coconut oil. Yeah, straight from my bedside table.
9 molar sodium hydroxide. Yeah.
Base for the day. She's
Our base.
basic.
Okay. What'd you call me?
Alright, and then we got stearic acid. And then we have some like flavorings and colorings for, making the soap all custom and cute on the back end, but we'll get to those later. So first things first is we just gotta like get all of our oils, mix them all together. So, Miss Hanukah,
Yes.
you're gonna be doing most of the work today.
Thank God.
So if you could please just dump all of our olive oil into
Every
our,
single one?
into our beaker, yeah.
Hey, you do it for me. Thank you.
Alright, and dump all of our coconut oil.
Oh, we're
and mix
mixing
it. Yeah,
oil?
we're mixing everything together. Get a nice a blend. This is my whole thing that I was thinking about yesterday. Oil-based
Tell me.
lubes.
Yeah.
Why is it based? Just use the oil. It's cheap and it's real slippy. Yeah, so we're just gonna mix it all together until it all melts. I have a little thermometer. So we're aiming for like a 45 to 50 degrees C, just to get everything melted and a little bit warm.
Like me, a little bit warm. And a 35C.
Our oil is a little bit heated up, so now we can add our base. So our 9 molar sodium hydroxide, that's a pretty concentrated base,
Okay.
which is just the opposite of an acid.
This is where we drop the base.
So we're going to double team this beaker.
Okay, I can't wait.
It's gonna be super hot. All right, so you're going to start swirling, and I'm gonna add our base.
Okay, the oil is viscous, and it is, ooh, that base is faster.
Yeah.
Oh, it is becoming much thicker, and also darker. It's going from a lovely oil color to a lovely swamp water color.
Yes.
Think swamp water and pickle juice. Yeah, it's very thick.
All right, and it's only going to continue getting thicker. So,
Just like me.
the only two parts of this transformation is just the oil and the base, but we do need to stir it for quite a while. So we're going to take turns stirring. So the person who's not stirring, just try to entertain the person who is
Can I bring out the magical prop?
You can bring out the magical prop.
I have my favorite. It's dry ice.
Ooh, I love this sound.
I know, me too. It's so what are you doing?
Now that I have you captive here stirring, let me explain a little bit of what's going on today in our little beaker there. Oils and fats, they're all comprised of these molecules called triglycerides, which looks like this, which are just 3 fatty acids, which are these long chains connected by a glycerol backbone. So when we add base to this oil, it performs a reaction called saponification, in which the fatty acids are liberated from the glycerol backbone. Right when we added the base and everything started to get thick, that's what was happening. We have all of these liberated fatty acids that are amphipathic, meaning they have a nonpolar portion of the molecule and a polar portion of the molecule. The tail is nonpolar, and the carboxylic acid at the top is polar. Nonpolar things like to associate with other nonpolar things, and polar things like to associate with other polar things. So what this causes, when the soap is curing, all of the fatty acid tails will want to line up next to each other, because that's a very stable interaction for them. And then consequently, all of the carboxylic acids will line up next to each other as well. And the carboxylic acids have a negative charge, so what they really want is to find something that has a positive charge to balance them out. And that positive thing in the case of this solution are sodium atoms that were brought into the pool by our sodium hydroxide. When all of these fatty acids start to line up next to each other and start to associate with some sodium ions, they start to form a very organized structure that's sort of like a sandwich of polar parts and non-polar parts. If we zoom out to a slightly larger scale, they form this very organized, larger matrix that eventually forms a kind of crystal, and that is what gives us our final soap product. We're halfway through the stirring.
ASMR science.
Yeah, wait, you're young, right?
Yeah, I'm 25.
My friend Alex turned 25 today. Happy birthday, Alex!
Happy birthday, Alex.
Turn the beat around! Let's do truth or dare.
Okay, great. Okay,
No one's gonna dare me to do a handstand though. Can you see my butt?
No.
Just
I
the
can
top of
just
it. Just the top of it. Now you can.
the
Yeah!
sound.
She did it!
Heidi.
Your mom's name is Heidi?
Heidi.
Heidi, this one's for you. Stir the soap up!
I squirted.
It's also getting thicker, by the way. Can everyone see
And
that?
more buttery looking.
Yeah.
The
My forearm
40
has
minutes.
not been this tired since I was 13.
This morning. What
Yeah,
should we-
let's
what
take a
should we do?
selfie. Oh my god. Grab your phone.
Me?
Yeah.
That's my dare.
This is getting to a very, like, this is what good sound like kind of place.
I almost said it earlier and I was like, they'll get it. They'll get it.
Alright, so we've been stirring for about like 40-ish minutes,
That's
and
bad.
it's thickened significantly. It's still a little bit runny. And so what we're going to do to kind of give it a little extra kick of soap stability, we're going to add some stearic acid, which is just it's a pretty long saturated fatty acid. So what this is going to do is we're basically just adding more very stable fatty acids to the solution. So when it comes to the whole setting up process of the crystal structure, we're just adding some more fatty acids that are going to work in our favor to create that crystalline structure. I'm going to aim for like maybe like a teaspoon-y kind of amount. Now you take over the stirring.
Would love to, and it's gonna get really thick.
And it should observe a pretty dramatic transformation. So our saponification has transpired, we've stirred it, we've gotten that reaction all going. It will continue going, it's going to cool down, waters are going to evaporate off of it, and that's what's going to harden it into like a bar of soap. But for now, we can add colors and flavors and stuff like that. So you've picked out the colors that you want to aim for.
Yeah. I want to go for a lilac.
I also have some scents to
Are those
pick
my
out
flavors?
of. Yeah, so...
What do we got? Vanilla
Mm-hmm.
and almond. Got it.
And...
What is that? Poppers? Is it poppers? Cut the camera. Cut the camera.
And if you could
Oh my
please
God.
add some drops of purple into our beautiful solution. Add a lot, yeah. Okay, it turned red. Interesting. Not an ugly color.
No. Not what I was expecting.
Not what I was expecting.
I wonder if we had a peek to it.
Yeah,
Like
let's
the
do that.
rose. I want to do it.
Yeah, you got it. It's all you.
Pretty. I think it's gonna look really gorgeous.
I think it will as well. Ooh.
What did I
This
say?
this is turning out. That's so pretty. Get into this soap. Look at how nice that is. Look at that color. Ooh. All right, now let's add some scents to it.
We got some almond. Just like a capsule.
Yeah, sure. That's probably gonna be very profound.
Maybe a little vanilla.
Just a dash.
What's the poison that smells like almond?
Cyanide.
Oh, she's
Do.
really thick.
Yeah, all that's left to do is to just pour it into a mold, and then we won't be able to see the final product for a little while because it needs time to set and crystallize and dry out a little bit. So I have 2 options for molds, aka things that I found sitting around the lab. So we have a hexagonal whey boat, and then a liquid reservoir that's kind of shaped like a V at the bottom.
I want the V. That would be a fun soap.
Okay, here. You hold, or I'll hold, you pour.
Can I take a little spoon out?
Yeah.
That's not the science term, but it is my term.
Yeah.
A little spoon. It's gonna be
Aw.
warm.
Oh, it's like strawberry color.
Yeah, is that good?
That's great. And now we wait.
One eternity later.
It's been about like 5-ish days since filming with Hanukah, and these are our final soap products. So you can see this is the hexagonal one. It has all these spots of not properly mixed in food coloring. This is the one from the triangle shaped boat. That came out pretty cool. But yeah, so the soap solidified after about a day. Then I took them out of their molds and they've just been drying on a shelf since then. I'll probably try to give one of them to Hanukah. Yeah, so this is our proper final product from the saponification experiment. Yay!
Meanwhile.
Hanukah, thank you so much for coming to the lab.
Thank you for having
Because I had
me.
so much fun today. Where can we find you out in the world?
You can find me on Instagram and Venmo at Hanukah Lewinsky. That's HANUKAHLEWINSKY. You
Yeah.
can find me there. If you want to find me on Twitter, it's exactly the same, but there's no Y at the end, so it's just at Hanukah Lewinsky. Where can they find you?
Oh my god, thank you so much for asking. They can find me on Twitter and Instagram at Adam the Chemist. And you mentioned that you have a Venmo. But I encourage everybody to go use your Venmo.
Please.
Because you're such a fantastic queen and you did a
Thank
fantastic
you.
job today. And you should go get some tips for it.
I love
Because in this lab, we tip our queens. So please go hop onto her Venmo, throw the girl some coins. And yeah, thank you so much for coming.
Thanks for having me.
And I'll get back to you as to whatever happens to this whole situation.
Yeah, you owe me a soap. If you give me a soap, I'll give you a free drink.
Okay.
Deal?
Deal.
Deal.
See you next
Bye.
time!